What's up everyone, welcome to my channel again, and this is another dump tutorial for you. So in this tutorial I'm going to show you in a very few lines that how you can implement transfer learning in Python. So my next target is to build a really long tutorial that involves transfer learning, and I'm going to cover a lot of models and how to do it and how to do it, like why to do it, especially like why do you need transfer learning. I'm going to cover these things in my next video, but in this video what I'm going to do is, like, in a very few lines I'm going to show you how you can use transfer learning in Python. So let's start. So we're going to need keras for this. From keras, oops, okay, start from here. From keras dot preprocessing dot image import image to array, yeah, and then also from keras dot applications dot VGG16 import preprocess input, and also from keras dot applications dot VGG16, and this time we are going to import the decode predictions. Import decode, yes, they have it, decode predictions, and again from keras dot applications dot VGG16, and then finally import VGG16. So I think we're done with our imports, and then let's declare our model as model equals VGG16. I think you guys all know about VGG16, like, I mean, you can search in the internet what is VGG16, like how the architecture is. So I'm not going to explain a lot about that. I'm going to make this video as short as possible. And then next step is, like, we are going to load an image from our drive. So here is our image, material.jpg, which is a MOG image that we are going to classify. I mean, that we are going to, like, predict whether it's a MOG or not, and how much it is considered as MOG using our VGG16 model, pre-trained VGG16 model. So what should it? Okay, we're going to name it MOG image. MOG image is equal to load image, and then, so I think we need the directory of this image, so let's copy the path. And then okay, I think we're gonna need conditions, and then our target size is, of course, equal to 2 to 4 comma 2 to 4. That's not a comma. So MOG image is load image, and then the directory path, and then target size. Fine, I think we're done with this. Loading the image is done. And then we are going to convert this MOG image into image array. So let's name it image is equal to image2 array, and then it's our MOG image. And the next stage is we need to reshape the data for the model. So let's do it. Image is equal to image dot reshape, one comma image dot shape 0. I'm not gonna write it again, so I'm just gonna copy from here, and then 1, and then 2. Main.shape 0, then okay, so let's run it so far. Let's see if there's a mistake. What? Okay, so this should be image2 arrays. That's a very big mistake. And then I think it's fine. So far fine. And the next work that is we're going to do is like, so we have to prepare the image for the VGG model. So that's pretty much simple. So image is equal to, so we're gonna need this preprocessing unit. So let's just copy it from here. Preprocess unit. Let's keep the name same. And then our next job is to predict the probability across all output classes. So that is going to be like, okay, let's just name it anything. Hula is equal to model.predict. So we're going to predict the image, and another thing is like we would like to convert the probabilities to class labels. So to do that, label is equal to decode predictions no, we need this. And lastly, I think we're going to retrieve most likely result, for example, the highest probability. So then label is equal to label, and lastly, let's print so we're gonna need in percentage, so asterisk 100. So I think so far we're done. Let's run it. So see, the coffee mug, so it has predicated as this as coffee mug 76%. And for example, if you want to see the image itself, then I think it's also possible. So let's print our mod image. Anyway, that's not necessary, but okay. Oh, sorry, I forgot to show you some more than important things. Uh, that is like, what if you want to see the model summary? We just have to do print model dot summary, and if you just run it, you can see the whole VGG16 model here with all the layers and also the total number of parameters and trainable parameters and everything. And then also, if you want to print the PNG file, the image file of the model, then you can also do that. So do that from keras.applications.vgg16. Oh, I think I have already VGG16, so I don't need to import that. So what I need is that I need to import the plot model. So from keras.utils.vis utils import plot model, and then plot underscore model comma to file equals vgg.png. I'm not sure if this will work because I've never used it, but I've seen people using that, like they can print the PNG file for the VGGNet. So let's see if this works. So from category VS, simple plot model, and then to file. Okay, this should work. Let's see. See, this works. So I think that's all. Anyway, I think you have learned, like, these are like very few lines of codes, few lines of codes. Like the Keras is so powerful that in so many few lines you can just implement transfer learning. So in the next video, what I'm going to do is like, I'm going to take a big data set and I'll implement transfer learning based on different models like VGG16, LX9, and also I'll introduce with some really newer nets like SqueezeNet and others, how to use them as how to use them and in terms of transfer learning, and also we'll see like the whole process, like starting with the dataset importing, and then using the transfer learning and getting the accuracies in terms of F1 score and everything. And okay, that's it for today.